Okay, scale diagrams is what this is talking about, and we're going to be using proportions again, cross multiplication again. So on this diagram, somebody drew their living room, dining room area. Obviously, when you go to draw something on a paper, you can't draw your actual dimensions, right? So this is the scale that's used.
Morning. I thought there were only 2 people in here, but then I looked further.
Oh, yeah.
I'm on guard duty. If you feel unsafe, I'm over there.
Okay, thanks. 1 to 50. Okay, so what does this mean? It means that every 1 centimeter on diagram equals 50 centimeters in real life. Okay, that's what the 1 to 50 means. So it's always the diagram to the real. So 1 centimeter on the diagram is 50 centimeters in real life. Okay? We're good with that? Understanding 1 to 50, that's what it means. Okay, and here it always goes in that order. Okay, as a fraction or as a ratio. Okay, so let's talk about the diagram. So the room okay, so the room was 6 centimeters on the drawing. So what I'm going to do is times it by 50. Okay, if you really want, this is what I'm doing. 1 on the diagram is 50 in the real. 6 on the diagram is how much in the real? Okay? And then if I cross multiply, it means I'm going to have to times it by 50. Okay? I'm not going to do that every time because it is going to be the same method. So everything, because of the cross multiply, is going to be times by 50. So 6 times 50 so 300. Okay, and then the other side of the room is 9. So 450. So that's the room. So how big is our couch in real life? Okay, so times by 50, so we have a 2.4. So the couch is 120. And 4 times 50 on this side of the couch. So 4 times 50 is 200. And then we'll do our table. So how big is the table in real life? Okay, so 2 times 50, we can do that in our head. 2 times 50 is 100 centimeters. And 3 times 50 is 150 centimeters. Okay, if I was ever mapping something like this out in real life, I'm probably not going to say something is 300 centimeters. Does anybody know what I could convert that to? Do you know what 300 centimeters looks like? Okay, what is like this long? A meter, yeah. So how many centimeters are in a meter? Do we know that much? 100, yeah. So this is, you could say that that's 3 meters long, right? In real life, that would make more sense to measure 3 meters. So then this would be 4.5 meters. Okay, so I'm just dividing them by 100 to see what kind of meters they are, because in real life it would make more sense. So 1.2 meters, 2 meters, or 1 meter by 1.5 meters. Okay, so sometimes you might run into some kind of conversions like that. If you don't know how many centimeters are in a meter, then if you run into it, just make sure you ask. All right, number 2. Okay, the biology class was doing work with a cell, like a human cell in your body. In the drawing, the diagram of the cell is 4.5 centimeters. The cell in real life is really small. It's 0.15 millimeters, right? Because you need to look at a cell through a microscope, so it's really small in real life. What scale factor was used for the drawing? Okay, so remember we always write it as, here's the drawing to the real. So the drawing was 4.5 centimeters, and the real was 0.15 millimeters. Okay. This is not going to work for me. The reason it's not going to work is because this guy is in centimeters and this one's in millimeters. So what do you want to do here? Would you like to change this to millimeters or this to centimeters? Which one would be easier for us? I think this one. Okay? How many, so if you have a centimeter, how many millimeters are in it? Do you remember that one? There's 10 centimeters, or 10 millimeters. Okay, so there's your 1 centimeter. There's 10 millimeters in that. That's what that one is, okay? So I'm going to times this by 10. Okay, so this looks better now. I have millimeters to millimeters. Okay, when we write ratios, it's nice to have one of the sides with a 1. So I'm going to pick the smaller side to be a 1. So what does this ratio become? If I want this ratio to be something to 1. So we're going to do this divided by that. And then I get 300. So the ratio is 300 to 1. That's the ratio, which is telling me that my drawing of this is 300 times the size of it. Okay? Because remember when you look at a cell of your body on a microscope, like how small it is? So when you drew it on the page, it was 300 times larger. Okay? Did you notice that this one was 1 to 50, which means real life is 50 times larger than the drawing. Okay, and then this one means the drawing is 300 times bigger than the real life. Okay, next question. If I asked you to draw something with a scale factor of 112%, my question for you is, would you be making something bigger or smaller? Okay, so if you were to draw something 112% the size of what it is it going to get bigger or smaller? What's your instinct say? Did you write bigger? 112% makes something bigger. Okay, next, if you times something by 0.75, if your scale factor is 0.75, would it make something bigger or smaller? What do you think? Would you pick smaller? 0.75 will make something smaller. And what if something is 4/9 the size? If you times something by 4/9, would it get bigger or smaller? Did you pick smaller? Okay, so if something is written as a percent, you compare it to 100. If it's over, you're going to get bigger. If it's under 100%, you're going to get smaller. So 90% of something is actually smaller. 112% was bigger. Okay? If you're comparing just numbers, if you're a number that's over 1, you're going to get bigger. If you're less than 1, you're going to get smaller. So that's why 0.75 got smaller. And then fractions, same idea. Is it bigger or smaller than 1? So that's smaller than 1. Okay, 2 questions left, I think, right? What was the scale factor used on a plan? An actual length of 6 feet is represented by 5 inches. Okay, so we have what's the drawing and what's the real. Okay, so on the drawing, we represented this on the drawing with 5 inches. And that 5 inches was used to represent 6 feet. Okay, so 5 inches on the drawing was us representing 6 feet in the real life. Okay, on this one, this is not good. This says inches and this says feet. So we can't do this. So what should I do? Do you want to convert this to feet or do you want to convert this to inches? What would maybe be easier for us? I think I would turn this to inches, right? Do we know this is a foot, right? A meter or a ruler is about a foot. Okay? How many inches are in this thing? Do you remember the conversion with inches and feet? You know that number? There's 12 inches. So I'm going to times that by 12. 12 inches are in 1 foot. So, every 5 inches on the drawing would be 72 inches in real life. Okay, now I'm going to change the smaller one to a 1. So what is the ratio? 1 to every 1 inch is how many inches? So I'm going to do this. And I'm going to divide. So every 1 inch on the drawing is 14.4 inches in real. Okay, every 1 inch is 14.4 inches. Okay, the last question. Okay, I have a billboard. Okay, so we know how big billboards are when you see them on the highway, right? They're massive. So I want to take this billboard and I want to be able to fit it onto a diagram on a piece of just my paper. And my paper is 20 centimeters by 15 centimeters. Okay, so what I'm trying to do is trying to obviously reduce that size and shrink it so that it fits onto that. Okay, this is in meters, this is in centimeters. That's awkward to work with. So, can you change this number to centimeters? So what do we know about a whole meter is, do you remember that number? 100? So 450 centimeters, 350 centimeters. Okay, so I'm obviously going to try to be shrinking this. So what would I have to divide by in order to get to 20? Do you know how to do that? So I'm going to go 450 divided by 20. So I'd have to divide by 22.5 to shrink it. Okay, 350, what would I have to divide by to get to 15? 23.3. Okay, now here's what we're going to think about. When you're shrinking it, you have to pick something bigger than this. So maybe I'm going to pick the number 24 or 25. Okay, when I do a scale diagram, I have to pick something bigger than this to shrink it enough to fit it on the page. Okay, because if you pick 22.5, this would fit on the page, but this one wouldn't fit on the page. You wouldn't shrink it enough. Okay, so what do you want to pick, 24 or 25? Doesn't matter. Should we just pick 25 because it's just a nice number? Okay, so we're going to shrink by 25. That's our idea. We're going to shrink it by 25 so that it will fit on the page. Okay, so now what's my scale? Every one on the diagram will be 25 in real life, right? Because my diagram is smaller than the real life. Okay, so let's just see what would it look like on our page. So if our page was 20 by 15, so if I was to shrink this by 25, it's 18. So that fits on my page. And if I was to shrink this by 25, it's 14. And look at that. I can take my piece of paper and then I can work with drawing my billboard on my paper. Okay? And it's okay to have extra room on your paper, right? Think about drawing a diagram. It's okay to have space around there, but you just need to make sure it fits on your page.